Hello everyone, I am Rakshita Kodanpur from STM College of Engineering and Technology, bearing USN 2SD22EC063, and I am from Electronics and Communication Department. This video is a part of the CT activity for the subject Computer Communication Networks under the course instructor Dr. Sunil Matad sir. The topic of my project is designing and implementing a subnetted IPv4 addressing scheme using CISCO packet tracer. The project is divided into three main parts. The first part is network design and subnetting. The second part is device configuration using CLI, that is command line interface. The third part is network testing and troubleshooting. Before moving on to the design, let me briefly explain the basic of IPv4 addressing. IPv4 stands for Internet Protocol version 4. It is the most widely used protocol for assigning addresses to a device in a network. Each IPv4 address is a 32-bit number divided into 4 octets, represented in a decimal format. For example, which is shown here, 192.168.10.1. An IPv4 consists of two parts. The network part identifies which network the device belongs to. The host part identifies the specific device with that network. To divide large network into smaller ones, we use subnetting, which involves assigning subnet masks. This helps manage traffic more efficiently and improves security by isolating different departments or segments. In this project, we apply IPv4 subnetting to design a structured and efficient network topology. Coming to part 1, which is network designing and subnetting. The design is implemented in CISCO packet tracer. In this part, I'll explain the overall network design. The network consists of two routers, router 0 and router 1. Each router is connected to two switches. As you can see, the router 0 is connected to switch 0 and switch 1, whereas the router 1 is connected to switch 2 and switch 3. And each switch is connected to different PC. This represents 4 different departments or subnet in an organization. To make communication efficient and secure, I used IPv4 subnetting to divide a larger network into a smaller subnets. Now, let us configure the IP address for PC0. For PC0, I am going to give the default gateway as Now, let us configure the IP address for PC1. Similarly, let us configure IP address for PC2. Similarly for PC3. Next, I configured router 0 and router 1 using command lines like which is shown here. Now that the overall topology is ready to test and troubleshoot, now let us come to the part 3, which is testing and troubleshooting. In this final part, I tested the network connectivity using the simulation. Let us test and troubleshoot this topology. Here you can see the communication is happening between PC0 and PC1. The source PC was PC0 and the destination is PC1. The status is showing successful. This implies all responses were successful, which confirmed proper routing. If there were issues like timeouts or destination unreachable, I would troubleshoot by checking the IP address, verifying subnet mask, making sure interfaces are up using show IP interface brief. With this, I would like to conclude that the IPv4 network topology was successfully designed and configured in Cisco Packet Tracer. All devices communicated properly, indicating that IP addressing, subnetting and device configuration were done successfully. This result demonstrates the following key aspects of IPv4 network design. Proper IP addressing. Each device in the network, PCs, routers, switches, servers, was assigned a unique IPv4 address that falls within the correct subnet range. No IP conflicts or misconfiguration were detected. Correct subnetting. Subnet masks were appropriately chosen to divide the network into logical segments. This ensured that devices within the same subnet could communicate directly, while devices in different subnets relied on routers or inter-network communication. Device configuration. The device, especially PCs, routers, had their IP address, submask and default gateway configured correctly. The default gateway enabled PC to send packets outside their own networks. I successfully designed a subnetted IPv4 addressing scheme, configured the device using CLI and verified all connectivity between all parts of the network using Cisco Packet Tracer. Thank you for watching.